Hi guys, sorry that we aren't all meeting together this week, but we are still going to learn some really fun stuff. So this is actually one of my favorite things to teach, and I had a bunch of different handouts, so I will have all of those available on the website for you to print off as you want, if you want to have them under the resources page. But we are going to do a review from Algebra 1. We learned all about linear equations in Algebra 1, so it should be a review. We're going to talk all through that, and we're going to talk about how this is going to make a difference in what we've been doing, and then we're going to move forward and use the tools that we have here with our linear equations and what we know to then solve quadratics, which is what we will be starting next week. So all last semester, we've had equations, we've had expressions, we've had numbers and variables, and we've moved them around, and we've gotten an answer. But as sometimes we ask, what does that answer mean in the real life? So we're moving into what does that mean in the real life, and actually getting to see opportunities for where we use it every day, and what it can mean and how we can solve through some problems. So as we get started, chapter 10 is all about linear equations, and I'm going to talk over all of it. It might not be in the exact same order as the book. We'll cover all the concepts of it, and then I will put your homework stuff up online. So the first thing that I want to discuss is vocabulary and words that you might hear and things that remember how we've talked about before, a lot of times the same thing can be said multiple ways, and so then it can get a little confusing. So when we are talking about an equation, a first degree equation with two variables, remember that first degree simply is your exponent here. So it means an exponent with the power of 1. So that is a first degree equation. So in this chapter, we will not be dealing with any y equals x squared. These are second degree equations. These are the quadratics that we have learned. So we're going backwards to first degree equations where a y would equal an x. So in this can also be called a function. A lot of times you'll have someone say solve the function, or if you're on a test, it'll talk about a function. What they will often do is write fx equals maybe x plus 3, okay? The function of x is the same as the y. It simply means what is your answer when x is a number. So it's telling you the number that you're going to fill in there. So first degree equations can be called functions. They also can be called slope equations. They can be rate of change equations. It can be a proportionality. It can also be called an equation of a line. So as long as you have an equation that's a first degree equation, it will always be graphed like a line. Okay, so this is what we're looking at. So as you move through, or as things are said different way, find slope, find an equation with slope, or rate of change, a function, proportionality, equation of a line. It's all the same thing. This is what we're doing, okay? This is a direct proportion. So a direct proportion means that when you affect one thing, you're going to affect the other. So for the holidays, my weight is in direct proportion to how many slices of apple pie I ate each week. Okay, so if the number of pie slices goes up, then my weight on the scale will go up. Okay, in the same way, the number of free throws that you make is in direct proportion to how many hours you practice. So if the hours you practice goes down, then the number of free throws that you make most likely will go down. So these are all graphed as a line. So this is what we're working towards. You can also have inverse proportions, which means the more that I run, then the fewer cookies I will want to eat. So those are also proportions, but it is still graphed as a line, okay? So that's what we're going to be working through and talking about, okay? So we are moving from simply solving an equation, getting an answer, having a number, to what does that number actually mean, okay? One concept that you guys all have or are quickly moving towards is driving, okay? So one simple formula that is used all the time is the distance formula. Distance equals rate times time. How far you go is directly proportional to how fast you are going times the time that you are traveling, how long you continue to go at that rate, okay? So if your time increases, your distance will also increase, okay? Or if the rate in which you are going increases, the distance that you travel will also increase, okay? So let's just look at a really simple one. If I have y equals 2x plus 1, okay, we want to solve for y. We could have a set of tables. So if x is 0, I'm going to put it on this side just so that it relates. If x is 0, then y would be 1. If x is 1, and I plug in 1 there, we'd have 2 times 1, which is 2, plus 1, y is going to be 3. If x is 2, y is 5. So we now have answers for y when we have a value for x. The interesting fact about these numbers that we are getting is that they are coordinates. Remember that we can graph everything as an xy coordinate. So when x is 0, y is 1. When x is 1, y is 3. When x is 2, y is 5. So now the answers that we had been getting for our equations actually have a place that we can put them when we graph them. Okay? So with these basic variable equations, we are going to be working with 2 variables at this time. Okay? We will only have an x or a y. It could be an h and a k. It could be a b and a n. But there will only be 2 variables for it. So there may be additional constants that are added, but we are only going to be working with 2 variables at this time, okay? So as we solve for one of the variables, we will get an answer for the other variable, okay? So the way that we go through, remember I like to give you little steps to work through. The first thing that you do is you fill in every bit of information that they have given you. Okay, and then the second is you solve for what you don't know. So in many ways, we could have an equation, or we could figure out the equation of what it works out. And as you work through, you might have different things. You're not always solving for the answer that's alone, like in the distance equals rate times time. In this one, we could be solving for, I could know distance. I could know that I drive 100 miles and it takes me 10 hours to go 100 miles, okay? So my rate is 10 miles an hour, okay? Or I could say I'm driving 100 miles and I am going 50 miles per hour. How long does it take me? It's going to take me 2 hours. Okay, so you might have multiple options, but you're going to have 2 knowns, okay? And then we're going to fill in what we know, and then we solve for what we don't know. Okay, so I'm going to do a word problem. Okay, so we love Australia. You guys know I love Australia. So there's a company, and we've decided to make boomerangs, okay? So the boomerang business makes an $8 profit on every boomerang, okay? So it's $8 for each boomerang, right? The costs are $64,500 a year. Okay, so that's going to be all of your electricity and your supplies and everything. So they want to know, what is the relationship of my profit between boomerangs and how many boomerangs I sell and the profit that we know. Okay, so we don't know what the profit is. We want to know what the profit is, and they're asking, what is the relationship between our profit, which is the money, and the boomerangs. Okay, so those are our two variables. Well, first, we know that we make $8 for every boomerang. Remember those key words that we have for math? If we say for every or for each, that's going to mean multiplication. Every time I sell one boomerang, I'm going to make $8. So this in itself is a proportional relationship. Okay, so it's a proportion within another proportion. So if I sell one boomerang, I've made $8. If I sell 10 boomerangs, I've made $80, and so forth. Okay, so first I make my boomerangs, but I can't just say, well, that's how much money I've made. My profit is $8 on every boomerang that I make. So I sold 1,000 boomerangs this year, so I just made it $8,000. No, we also know that there are expenses. Expenses cost the company money. If there's an expense, it is going to be negative. It comes off of what you've initially made, okay? So I have a negative expense here. So my profit is also affected by my expenses because I have a negative $64,500, okay? So my total profit will be based upon how many boomerangs I sell at this point, okay? So if we do sell 1,000 boomerangs, let's do 10,000 boomerangs so we have enough, okay? We would make $80,000 on boomerangs. We would subtract off our profit, or our expenses there, so our profit would be nope, that's not right. This is what happens whenever I go in off the top of my head. 15,500, okay, would be our profit. Now, if you are told what is your break-even point, okay, break-even means that your profit would be 0, right? So that's your net there. So or for your margin. So if I have 0 and I know I make $8 on every boomerang, they could also say, how many boomerangs do you need to make before you even make a profit? We're going to do the same as before. We're going to solve for our B, right? We're going to solve for our one variable that we have. He wants to go to the movies by himself. This is the same as we learned at the very beginning. So we have 64,500 equals 8B. B wants to be by himself. We're going to divide by 8. 64 divided by 8 is 8. Right? 8 goes into 50. 8 times 6 is 48. 20, so we've got close to, and 2, 16, 45. So I need to sell 8,625 boomerangs before I ever even make a profit on top of that, okay? Everything after this, when you sell 8,626 boomerangs, you're now making some money, all right? So these are proportional equations. Kind of a quick review of what we've done in the beginning, okay? So exactly what do all of these answers mean? Okay, so when we move forward and say, that's great, I got some answers, what does it mean? Ultimately, we want to see what these answers mean. Just like if you show up in a business meeting and they're going to give you a pie chart or a line graph or a table, because they want you to see what the numbers mean. So when we are looking at seeing, that means we are going to be graphing. Okay, so all first degree equations are lines. We just talked about that. Another way that I want to talk about, or things I want to say, is we often say that there is a constant. So the constant of proportionality is your change in y over your change in x. Okay? So this can be said as a constant whenever you, in algebra, when they talk about it as a constant of proportionality. They also talk about it as your rate of change. Okay? It is also called your slope. So this little k right here will be changed to an m if they're calling it slope. Okay? A lot of times they will say ratio or rate of change. So all of these things mean the same thing. We have a change in y over the change in x, just like when we talked about the more pieces of pie I eat, the more my weight is going to go up. Okay? So when we look at that, when we make it into an equation where we have one of our variables is dependent upon the other variable, remember distance equals rate times time. Okay? Our rate here can be any of these things. It can be k, it's our constant of proportionality. It'll often look like an m when we're doing lines and it's a slope. Okay? It can be in the distance equals rate times time, then it's a rate of change because it's a miles per hour that you've added on to it. So all of these things can fill in this extra space. So our proportion is dependent upon this rate of change. Okay? For our purposes here, we are going to talk about it in terms of slope. Okay? Slope tells us about a line. Okay? So we know that there's all lines. There's all kinds of lines. Lines go on in every direction, right? In both directions without stopping. There's different lines. And lines can be climbing up a hill. Lines can be going down a hill. Lines can be vertical. Lines can be horizontal. So we can have all different kinds of lines. When you have a line that is at a 45-degree angle, that means that for every tick on your graph, you have the equal amount along your y-axis, okay? So for every x, I have a y. So this is y equals x, okay? It's also y equals kx when k equals 1. All right? So if I go over 1, I'm going up 1. I go over 2, I'm going up 2. I go over 3, I'm going up 3. So if a line is going in a direct proportion where your constant is equal to 1, then you're going to have a 45-degree angle. Okay? I'm making this point because we're going to talk about this, and this is going to matter as we move into quadratics as well. So I want to get a good handle so visually you can see what that looks like. When your constant starts to go up, y equals 2x. Okay? So now we have something in front of the x that is more than 1. When your number starts to go up, the end of your line, if you think of this as a pivot point, the end of your line starts to go up. Okay? So as our numbers in front of x go up, our line is going up because now it means that our y is dependent upon a multiple of x. So when x is 1, y is now 2. When x is 2, y is 4. So now I have changed the slope of my line to where it is a much steeper hill to climb. Okay? So as your number goes up, your line goes up, it gets steeper. So what happens when your number goes down? Say I go to 1/2. Okay? So now I am less than 1, but I am still a positive number. As long as your line is positive, we're going to be climbing a hill. Okay? Now, this means when x is 1, y is 1/2. When x is 2, y is 1. So now we're going, if you're riding your bike, this is the hill you want to climb. Okay? So as your number goes down and gets smaller, your line is lowering. All right? So let's think about what would our equation look like if our line goes all the way down to where it is now just flat. It's tired, it's asleep. Specifically on our graph right here, every number for x ends up being the exact same number for y, right? So no matter what I put in for x, I'm going to have the same answer for y, okay? So that tells me, in this case, that I don't have an x anymore, and I would simply have a y equals 0, okay? It can also be a 0x in that term, okay? So whenever you have a slope, your slope ends up being 0 in front, or when you have a 0x, or when you have no x at all, because we know that 0 times any variable is simply 0, then you have a horizontal line. All right? Now, when we are working with linear equations, you will see y equals kx, mx, whatever, plus b. All right? This b tells you where your line crosses along your y-axis. It is called your y-intercept. So you might see y equals mx plus intercept. Okay. I also have this handout, linear equation slope-intercept form, that is going to be posted online. So let's look at an actual equation here to see what that looks like. So again, we're going from these equations that we are given. Okay, so now you have this equation. What does it actually look like? Let's make a table, and then we will plot the points, and then let's see if we can do one without doing a table using what we know. So first, we have x and y. We always want to put in the zeros. Zeros are the easiest thing to solve for. So your first 2 points should always be zeros. Okay, so when x is 0 or when y is 0. When x is 0, we just cover it up and we know that y is 1. Okay, when y is 0, we solve for x. So it would be negative 1/2. Okay, so those are 2 points that we automatically know. We can actually graph a line with just these 2 points. But we're going to add a couple extras just to make sure that we know where we're going. Okay? When x is 1, we know y is 3. And when x is 2, we know y is 5. So let's look at this. When x is 0, y is 1. When x is negative 1/2, we know y is 0. So there are 2 intercepts. When x is 1, y is 3, x is 2, y is 5. Okay? So we've got this pretty steep line. Okay. It crosses at two places. This, when x is 0, this is our y-intercept. Okay, means where it crosses the y line. When y is 0, this is our x-intercept. It means where it crosses the x line. These are also known as the zeros of your function. They are also called the solutions. Okay, so your 0 points here, when you have a graph, in this case we're looking at lines, when you have a graph and they ask for the zeros or they ask for the solutions, this is what they're asking for, the places where it crosses. Okay, that will tell you. So a line can have, when it's at the origin, it can have 1, 0, right? In this case, it could have 2 zeros, or if it were a horizontal line, okay, and you're looking at where it's crossing the x, it could have no x zeros, okay, for that. So there's a practical one, putting it on a graph. Now, let's see, can we graph something without actually making a table out of it? Right? So what if we have y equals 3x minus 2? Okay. We automatically know from our intercept that this negative 2 is where our line is going to cross. So I'm going to put a dot at negative 2 for that, okay? Now, our slope here is our rate of change. Remember, our rate of change tells us the change in y over the change in x, okay? So in this case, it's 3 over 1. It looks just like a 3, but it's really 3 over 1. So it says every time I go 1 on x, I'm going to go 3 on y. Okay? So let's look at this. If I go over 1, then x, I'm going to go 1, 2, 3 in a y, and that will be my next point. Okay? If I go over 1 again, I'm going to go 1, 2, 3. I have my next point there. Okay? So what we have is when I change for 1, if I know my intercept is 0, negative 2, I'm going to change 1, and I'm going to change 3. So 3 plus negative 2 is 1. Is that what we got? 0.11? Yes. If I change 1 again on the x value, I'm going to change 3, so plus 3. Okay, as we move forward, we have 2, 4. Did we get 2, 4? 1, 2, 1, 2, 3, 4. Yes. So our table confirms what we did without actually solving and getting some answers. All right. Lots of information in a little space. Okay. So what I wanted you guys to see is that the solutions that you get give you a coordinate point for you to actually graph. Okay. So our solutions are meaning something, and we're getting to move forward. Okay. We talked through rate of change, and to put those, and that's what our slope means. So I also have this handout for you guys. It says graphing 3 forms of linear equations, cheat sheet, point slope, slope intercept, and standard form. Right now what I'm going to do is I'm going to work through and show you how all of these forms are really the exact same equation rewritten. And we've done that a couple of times. That's what we've been doing all semester, is taking what we know, rewriting it in a way where we can get the information easier, we can understand it, we can simplify it. Okay, so when we have this basic form, our slope, okay, y equals mx plus b, okay, It's our first degree equation because both of our variables only have the power of 1, so it's first degree. We just saw that our proportion between y and x is dependent upon this rate. Okay? But our line can move up and down depending upon where the b is because it affects this proportion, right, with our coordinate points. So if our b is positive, then our line is going to move up on the coordinate plane. If our b is negative, our line will move down on the coordinate plane. We've also seen that our slope is dependent upon how it relates to the number 1. We looked specifically between horizontal lines and then moving up because our slope was positive. What if our slope was negative? If I have a -2 as a slope, this is rolling down a hill. This means that I'm going to go down 2 every time I go over 1. So if I go over 1, I'm going to go down 2. Over 1, down 2. So now, oops, I need to go through the origin. Now I have a line that is rolling downhill. So positive numbers mean you have a slope that is moving up. Negative numbers for your slope or your coefficient of x means that your line is moving down. So we're getting to where we can see what it looks like without actually having to solve all of those numbers and plug it in. Isn't that great? Okay, so when we have this form, this is called your slope-intercept form, okay? Because we know two things. We know the slope and we know the intercept, okay? Right? So this is your slope-intercept form. If you have y equals -3x plus 4, you can automatically tell me that it crosses the line at 0, 4, and that it goes downward at a pretty steep slope at 3/1, rate of change of -3, okay? Now, if we want to move that, if I haven't been given my slope, okay, or I have this, and I want to put it in standard form, remember where everything is just equal to our number, where our variable's on the same side, we are going to solve this equation for b. Okay? So if I solve the equation for b, I'm going to move my x away. So in this case, I have -mx plus y equals b. Okay? In the terms, they say ax plus by equals c. If you start your equation like this, it's simply the coefficient of x is a, the coefficient of b is y, and your constant is c. Okay? So we know that our constant relates to our slope-intercept. Okay? We know that our coefficient in front of x is going to be a part of our slope, or sorry, our y-intercept. Coefficient of x is going to be part of our slope. Okay? So they will say that your slope, when you're in standard form, your slope is equal to -a divided by b. So this is a shortcut. Okay? Often it's really hard to remember all the little slopes. They'll also say that your y-intercept is equal to c divided by a. Sorry, c divided by b. Wrong one. Okay? So if you can't remember those, let's see if we can take our standard form and make it look like our slope-intercept form. Okay? Slope-intercept says I need y all by itself. So we're going to take our standard form and we're going to get y all by itself. The first thing that we want to do is get rid of our x. So we have by equals, we've got a c over here, positive c, right? I want to move my x to the other side. So it's positive on this side. I'm going to subtract it. I've got to subtract it from one side, which means I've got to subtract it from the other side, right? So I now moved my a over. Now I still need y by itself. So I need to get rid of b. I do that by dividing by b. You can divide the whole thing by b, which really means dividing each one by b. So now I have y equals negative a over b times x plus c divided by b. Is that what we have here? Those are our answers? Yes. So our slope is negative a divided by b. Our y-intercept is c divided by b. We took our basic standard formula in our equation here, and we just rearranged it so it looked like something that was a lot more familiar to us. Right? So same thing. So those are two forms. That's standard and slope-intercept. There's another form called your point-slope form. Okay? And it says that if I am given one of the values, I know that my line crosses through the point 2, 4. Okay? So on the graph, I go through the point 2, 4. I don't know what direction it goes all around, but I know it crosses through 2, 4. Okay? And then I say, and I have a slope of 1. Okay? So it means for every 1, I'm going to go over 1. Okay? So I can go ahead and graph it. But what is the equation for that? So I know we're going to work with the point 2, 4. Okay? Remember, x is always your first term, y is your second term on it. So I have y minus 4. This is the point that I have. I've given you my slope is equal to 1. X minus 2. Okay. So now we simply solve. Y minus 4. We're going to distribute our 1. Distributing our 1 doesn't change anything. X minus 2. I still need y completely by itself, which means I move this 4 by adding 4. X plus 2. Okay? So now I know that my slope was 1, correct? And my y-intercept, it crossed the line at 0, 2, which when we graphed that, it did. We started at 2, 4. I go over 1 and down. Down 1, over 1, down 1. Yep. I crossed at 0, 2. It says that I crossed at 0, 2. This is the equation for the line. They say, what is the equation for the line when you have point, they give you a point and they have a slope. Okay? So different ways to have the same exact equations. They're just rewritten in 3 different ways. It solves all for the same exact line. So no matter what you have, you can figure that out. Now, where do you go when all they do is give you 2 points? Okay? So if you've only been given 2 points, for example, 1, 2, and 4, 8, and they say, give me the equation of that line. Okay, remember, for an equation of a line, we need to know what is the slope, and I've got 1 point, so I can use my point slope. What is my slope? Where does it cross the y-intercept? Okay. In this case, all we know are 2 points, so we have got to figure out that rate of change. We know our slope, which is also our rate of change, so same thing, is a difference in rise and the difference in run, okay? So our difference in y over the difference in x. Some ways to think about it is that if you were laying down on the couch, you've got to get up before you can move forward, okay? If you're laying in bed or watching Dude Perfect or something, okay? You've got to stand up before you move forward. So we're going to go up before we move over. We're going to go along the Y before we go along the X, okay? So rise, over, run. Same as it ends up looking like stair steps, so you've got to pick your foot up and then go forward. So those are all some little trick ways to think about making sure that your rate is the same. So in this case, if you need to mark your coordinates, absolutely do so. Okay? Remember, whatever one you choose to be your coordinate 1 needs to stay coordinate 1. Whatever one you choose to be coordinate 2 needs to stay coordinate 2. So in this case, I've got coordinate 2 is going to be my 8 for my Y and my 4. And then I've got 2 for my Y and a 1 for my X, and they are subtracted. So I have 6 over 3. My slope is 2, or 2 over 1. So I'm going to rise 2. I'm going to go up 2 points every time whenever I go over 1. Okay? So it's twice as steep as a regular direct proportion. So now that I have my slope, I can plug it in. So then all we need to know is where does it cross for your intercepts. Okay? Well, we know that our intercept is whenever x is equal to 0. Okay? So we can either graph it and figure it out that way and say, oh, well, I'm starting at 1, 2, and I know that I go, if I'm going backwards, that I would go down 2 every time I go over 1. It might be the origin. Or we're going to plug it into that point slope term. I like taking the smallest one. So we're going to do y minus our first y term. We know our slope is 2, and then we've got x minus our first x term, and then we're going to solve. Okay? So we have y minus 2 equals 2x minus 2. Okay? I'm going to move my 2 over, plus 2. Y equals 2x, and this is a big 0. There's my equation. Y equals 2x. Y equals 2x. Our intercept was 0. Okay? So we were given just 2 points. We were able to find the equation for the line in that. So now that we know that these equations actually show us something, and they show a line, we can use this to compare equations and compare different formulas and recognize what a line is doing, okay? So remember, if it's positive, it's going to be going up. The bigger that coefficient, the steeper it is. If it's negative, it's going down. If it's 0, it's going to be horizontal, okay? Another thing that we didn't look at was undefined. If you ever end up with a number over a 0, this is an undefined line, okay? Undefined slope, it means that it goes forever straight up and down. This is also a slope where you don't have a y value. So this would be x equals 2, okay? In this case, so whenever you've got y equals kx plus b, also mx, it's written different ways in different books, so that's why I'm showing you the different ones. In this term, you don't have y, okay? So all you have is an x term. So this would be a 0, okay? In that case. So if we've got two different equations, let's look at the equations y equals 2x plus 1 and y equals 2x minus 3. If I asked you to compare these two lines and tell me if there's anything specific or valuable about them, that you're like, hey, I know something about those lines, we can immediately look and see that the slope of both of the lines is 2. Okay? The slope of this first line goes through the point 1. So I've got a 2 slope through the point 1. The slope of the second line goes through the point -3. The special thing about these lines is that they are parallel lines. Anytime you are asked to compare two equations that have the exact same slope, okay, so your rate of change, your constant, your slope is exactly the same, they are going to be parallel lines because every point will move, differently. You will rise and run exactly the same distance all the way across. So those are parallel lines. So we can use what we know about our equations to just look at those and say, oh, that's parallel lines. They will never meet. If you are given y equals 2x plus 1 and y equals 2x minus 3 and asked, will these equations, will these functions, will these lines ever meet? You can immediately look and say, no, they will never meet. There will never be a point in which they cross. Okay? Now, if your slope is different, y equals 2x plus 1, y equals 4x minus 3, when your slope is different, they will meet at some point. Okay? To find out the point where they meet, we set them equal to each other because it's the place where they end up at the same place, right? So they're either, if both lines cross at this coordinate, x and y, then their x and y coordinates are going to be exactly the same. So if y is the same for both of these, that tells me y is equal to 2x plus 1 is, what if I write it backwards this way? Okay, y is equal to 4x minus 3, y is equal to 4x minus 3, y is equal to 2x plus 1, y is equal to 2x plus 1. I have all equal signs. So 4x minus 3 is equal to 2x plus 1. Okay, see how I did that? So now all we do is solve for x. I'm going to move these because they're smaller. So we've got 2x on this side. I'm going to move the 3. So we know that the coordinate point where they cross, x, is equal to 2. So now we can use that in any one of these equations. So I'm going to plug it in here. If x is 2, y is 5. These two equations meet and cross at the point 2, 5. Right? Now there's a special one when they meet and cross. What if they meet and cross? Nah, that's a bad drawing. At a right angle. Okay? When they are perpendicular. Let's just think about these lines in the first place. Okay? Let's do an easy one. Okay? So I'm going to use a 45-degree angle here. So I have a slope of 1. This is y. We already know y equals x. Okay? So I need to cross it going the opposite direction. So automatically, I know that it needs to be negative, right? So the difference in this one is that one line is positive, one line is negative. In this case, my line is going down exactly the same as it's going up, so y equals negative x, right? These cross where they are perpendicular. if I have y equals 2x, let's look at this line. So this was a steeper line, right? Y equals 2x, because for every 1, we're going up 2. Okay. So to have its right angle line, okay, its perpendicular line here, we know it's negative. But let's look at it. Does it look as steep? Well, I've got my, let's put in our dotted line for our y equals x. This is y equals x, our direct proportion. So on the first one, our line number 1 here, it is steeper than our direct proportion. Our line number 2 is less than our direct proportion, which means it has to be less than the number 1. It will always be the reciprocal of your other number. So proportional lines will always be a negative reciprocal. So let's just, for fun, play this game. What line crosses perpendicular to y equals 3x? I know it has to be negative, and it has to be the reciprocal of 3, which is 1/3. So the line that is directly perpendicular to y equals 3x is y equals negative 1/3 x. Okay. So if I have y equals 6x plus 3, write me an equation for a line that is parallel to this one. Okay? So if I want a line that is parallel, or an equation that is parallel, we know the slope has to be the same, and all I have to do is change the intercept. It can be any number. It could be 20. Okay? These two lines are parallel. Let's start with y equals 6x plus 3 and say, what is the equation of the line that is perpendicular to this line? Okay? So we're going to do y equals negative. We know it has to be negative because one of the lines is positive. You're climbing a hill. The other line you're going to be going down the hill. We're going to have the reciprocal here. 1/6 x plus 3. Okay? So those are simple ways without actually having to solve it. We didn't have to plug any numbers. We didn't have to make a table. We were able to write some equations of the line. Okay? So on your homework, you'll have some just identifying slopes according to what the equations are. Okay? Let me see. We did reciprocals. Okay, let's look at, let's do another one where we can compare them. Okay, so if we have y equals 3x plus 2 and y equals negative 1/3 x, okay, we want to know, and we are told we have these two lines. Do they cross? One, do they cross? Yes, we know that they cross somewhere because they don't have the same slope. 2, we want to know, do they cross in a special way? Yes. This one's 3 and this is negative 1/3. So automatically I've got negative reciprocals, so I know that these are perpendicular lines. So the next question is, where do they cross? Okay, so back to the same thing. If they cross, that means that they share an XY point, correct? So no matter where they are at, there is going to be one point that they both have in common. And at that point, their X values will be exactly the same and their Y values will be exactly the same. So when we know that we already have them set up where y's are equal to each other, we can set the rest of the equations equal to each other. Okay, so I know that 3x plus 2 equals negative 1/3 x. Okay, so we're going to move the x's to one side. So on this side, I have 3x plus 1/3 x equals negative 2. Okay, now in this case, remember, we have to look at the denominator, or we can clear the denominator, either way. Okay, if we clear the whole denominators, we're going to multiply the whole thing by 3. So we have 9x plus x equals negative 6, because I distributed this 3 all the way across. If I wanted to combine them, I would need to change my 3 into a 9/3, and I would end up with 10/3 x equals negative 2. And then we need to get rid, we would cross multiply. So I still end up with 10x equals negative 6. Okay, and this way I've got 10x. So both ways work the same thing. The combining the variables with different denominators, often like we get hung up there. Okay, so now I've got 10x equals negative 6, so x equals negative 6/10. This is not simplified. They're both divisible by the number 2. So our x value is negative 3/5. Okay, so these two lines cross at negative 3/5. And something else. Okay, so either we can solve both of these equations for x, set the x is equal to 0 and find out the y, or we can just take our negative 3/5 and plug it in. So I'm going to plug it in over here because it didn't have as many things. So I've got negative and negative, which is a positive. My 3's cancel out. The y value is 1/5. All right. So that is your intersection point, negative 3/5 and 1/5. All right. Quick and painless. Let's see. Make sure I cover everything. Okay. That is all of everything that we needed to do for linear equations. All right, so that's a quick review. I know we did that in Algebra 1. We're going to use these steps as we move into quadratics next week. So I hope you guys have a wonderful week. Enjoy your time, and I will post up your homework and some practice stuff online. So happy January 2022. See you guys next week.